The three of us are speaking right after the end of the COP26 summit, where, for the first time, the agreement between almost 200 nations specifically mentions coal and fossil fuels as energy sources the world needs to move away from. But these mere mentions are a small victory. Despite the urgency conveyed by scientists, Indigenous peoples, delegates from the Global South, and youth, the final draft of the agreement includes concessions and compromises that so far prevent the world from limiting warming to 1.5 degrees. The agreement's language was softened significantly, especially when it comes to the urgency of ending the use of coal. For example, rather than phasing out coal full stop, we're now pledging to phase down unabated coal power. Critics say this leaves the door open for continued fossil fuel use, in part because it allows heavy polluters to argue that we'll someday abate emissions with new technology that's so far unproven. One of those technologies could be solar geoengineering, or artificially cooling the planet by reflecting away sunlight. It wouldn't reduce emissions directly, but it could help us slow down rising temperatures. There are caveats, of course. For one, the technology is not ready to be deployed on a large scale yet, and there's no solid timeline of when that might happen. We also can't fully know all of the potential negative effects in advance, and the very idea of coping technologies could give the world's worst polluters an excuse to keep emitting as usual. Still, the need to mitigate climate change is so pressing that maybe we have to keep moving every possible solution forward to have it in our toolbox in the future. Imagine that by 2035, the world isn't meeting the greenhouse gas reduction targets necessary to avoid the worst effects of climate change. Should we consider solar geoengineering? Why or why not? Here today to discuss with me are two pre-eminent climate scientists, Katharine Hayhoe, Chief Scientist at the Nature Conservancy, and David Keith, Professor of Applied Physics at the Harvard School of Engineering. Thank you both for being here.
Thank you for having us.
Here.
So let's start with David. Give us your quick take. What is solar geoengineering, and should we consider manipulating the Earth's climate?
Solar geoengineering is the idea that humans might intervene in the Earth's climate system to reduce some of the consequences of increased carbon dioxide, so reduce some of the consequences, warming and other changes. So from my point of view, the question isn't should we intervene in the Earth's climate, because the purpose of this, as I described it, would be to reduce the amount of climate change. It's not to make some artificial designer climate. And to me, this really comes down to fundamentally weighing the risks and benefits of doing it. And most importantly, the benefit that you kind of alluded to, which is the risk that you kind of alluded to, which is the risk of moral hazard or mitigation inhibition, the idea that talking about it will somehow encourage or reduce the force to cut emissions, encourage emissions to keep going.
Katharine, do you have anything to add about what solar geoengineering is?
Well, first of all, I want to point out that we are already conducting a truly unprecedented experiment with the only home that we have. We are putting more carbon into the atmosphere every year, we humans, by digging up and burning coal and gas and oil primarily. That's 75% of it. 25% comes from deforestation, land use change, and agriculture. We're putting more carbon dioxide and heat-trapping gases into the atmosphere than any time as far back as we can go in the history of the planet. We have never done this before. And so that is why, while scientists like me study what's going to happen as we continue on this pathway, we know that there's the potential for some truly unpleasant surprises as we push this planet further and further from where it's supposed to be. So we are already doing this. And what people are talking about is deliberate geoengineering of the planet to reduce the impacts that we're having. It's like you're doing something that has tremendous side effects, and you're talking about, doing something else to reduce the side effects. Of course, the best thing to do is cut our carbon emissions as much as possible, as soon as possible. And the more we do, the better off we'll be. But we also know that there are ways to take carbon out of the atmosphere, and these are also types of geoengineering. Large-scale tree planting is a form of geoengineering. Conserving, protecting, and restoring ecosystems so they can take up more carbon is a type of geoengineering. Nature-based solutions like smart agriculture, cover crops, restoring coastal wetlands. These are all ways to take carbon out of the atmosphere where we don't want it and put it back in the soil and the biosphere where we do. But the type of geoengineering that we're talking about today is not one that takes carbon out of the atmosphere and puts it into the biosphere. It's one that actually mimics the effect of a volcano on the Earth's climate. We know that when volcanoes erupt, they spew particles into the upper atmosphere if they're a very powerful volcano, and those particles act like an umbrella to reflect the sun's energy back to space, and so that cuts down on some of the energy that we're getting. It temporarily cools the planet for anywhere from a few weeks to up to a year or two for the biggest volcanoes, but it also affects the amount of solar radiation that's coming in, which of course we need for our crops, our plants, our ecosystems, and more. So this in a nutshell is what solar radiation management, or SRM as people often call it, is about. And this is what David is the expert in.
So David, what's needed to figure out if solar geoengineering is really an effective solution? How do we test it?
What's needed is more research. And I think the important thing to say is the research is very much related to the same way that climate science or atmospheric science now works. So while this idea is in some ways a kind of horrifying new idea, it represents a human involvement in the natural world that is different from what we've done before, I think, and has real ethical consequences. And there are certainly some things new about it. It's in many ways built on top of technologies and scientific understanding that we've studied for hundreds of years. So, if you think about the kind of solar geoengineering that's adding aerosols to the stratosphere, and there are quite a few different kinds, that builds on this long history of atmospheric science, of understanding the stratospheric circulation, understanding how volcanoes act, understanding the aerospace engineering of how we might put materials there. And so all of that is something we're already doing. We're really talking about applying some of the broad sweep of atmospheric and climate sciences to this particular problem. So for example, one of the obvious questions, if you add any aerosol, you're going to harm people because aerosol pollution is the biggest killer, much bigger than climate right now, 4 to 8 million people a year. So right away, when I started working on this, the kind of ethical question is how many people would be harmed if you added aerosols to the atmosphere? So we were able to produce some papers that give reasonable answers to that because I collaborated with people who are already answering almost the same question. I collaborated with an expert who was one of the top people, Steve Barrett, understanding the atmospheric effects of aviation. And he had a model that already dealt with sulfur in the atmosphere well, and a health effects model. We just applied that to solar geoengineering. And that's an example of the kind of thing one could do again and again to use our current tools to improve our knowledge about how effective this might be in reducing the climate risk we actually care about, which isn't just temperature, but it's local changes in water availability or extreme events or sea level, and then understand what some of the side effects or risks might be. So what it might do to damage the ozone layer or to increase aerosol pollution or to alter the way crops grow. And these are all things that are not knowable perfectly. There's no way we'll know exactly how it will work, but they're things where we could know a lot more if we had a focused research effort.
And Katharine, what are some of the main arguments against SGM?
Well, as David pointed out, there's still a lot of questions we don't know the answer to. And so people often ask, as a climate scientist, what keeps you up at night? And as a climate scientist, there's a long list of things that keep us up at night, like methane emissions from thawing permafrost and changes in ocean circulation. But one of the things that I think is plausible, and of course David can tell us how plausible it might be, is that the technology required to do solar geoengineering is not ultra high tech. There's a fair number of countries that could do it if they wanted to do it. And so one of the things that keeps me up at night is if a country decided unilaterally that they were going to do it. It's like giving every single person on the whole planet a shot of a brand new untested vaccine. What do you want to do first before you do that? You want to test the vaccine. And so that's why this research is so important, not because we necessarily in North America and Canada or the US might want to do it. We might decide we don't want to do it. But how do we know that if we don't study the potentials and the risks and what it would accomplish? And what if somebody else does it? We need to know, and we would better know ahead of time why they wouldn't want to do it and clearly communicate that too if that was what we concluded.
If I can pile on, I think the real political question now is whether or not there should be a real research program. So the way you phrased it asked a kind of hypothetical 2030 question. And my answer to the 2030 or 35 question is, well, it depends on the politics and science when we get there. Mm-hmm. And I certainly am not going to argue we should or shouldn't do solar geoengineering right now. I think it's plausible to argue we should have a global moratorium against doing it. Mm-hmm. But what I do think is clear is that we ought to know a lot more. Mm-hmm. And not everybody agrees. There are strong groups that argue we shouldn't. So in the fallout of an experiment that a colleague and I were involved in Sweden, a prominent Swedish indigenous group, the Sami Council, has argued pretty carefully in a well-written public letter that there shouldn't be research, that this is fundamentally going against nature and research is a bad idea. And very entitled to that point of view. But my view is there are legitimate questions about research, and that's really where the politics are now. And to me, the biggest one, the one that you hinted at, is this question of moral hazard. Does simply doing the research, knowing more, lead to a risk that it will somehow be abused? And I think the answer is yes. But I want to give one really important piece of kind of both ethics and history. So there were many people, most prominently Al Gore, who argued very strongly that we should not put any effort into really understanding more, doing research and development of climate adaptive measures, measures that reduce the local risks to people and environment by things like making more drought-resistant crops. And now, what has in fact happened is, and the argument, sorry, I'm losing the thread. The argument that Gore made was that giving any credence to adaptation would lessen the necessity to cut emissions. It would take the focus off the most important thing we all agree we should be doing, which is cutting emissions. I think in hindsight, that argument was both unethical and perhaps wrong. It was unethical because it's unethical to say that local people, say local poor people, shouldn't be able to protect themselves from climate risks. And also it appears in hindsight to be wrong because in fact, we now have much more attention to cutting emissions than we did when Gore made those claims. He's changed his mind. Not as much as I think either I or Katharine would like, but much more attention to cutting emissions and much more attention to what's now called climate resiliency, but it's basically the same as what we used to call adaptation. So we can walk and chew gum at the same time.
And I am a climate adaptation scientist. That's what I do. I study specifically the impacts that climate change is already having and will have at the local to regional level for cities, provinces, states, water districts, and more, depending on the choices that we make. So I look at what's going to happen if we continue to depend on fossil fuels as our primary source of energy versus what's going to happen if we can transition to clean sources of energy. In other words, the minimum we have to adapt to no matter what, it's going to happen anyways, versus what we will avoid. And here's the interesting thing. Even though my research is specifically used in adaptation to prepare everything from our food systems to our water systems to our infrastructure design for the impacts of a changing climate, the first big study that I led, which was for the state of California, that looked at how climate change would affect everything from wine grapes to water supply, that clearly showed the difference between a higher versus a lower future, it actually led to and was directly quoted in the governor's executive order that made California the first state in the whole country in 2004 to have a mandatory greenhouse gas emission reduction target. So far from discouraging mitigation, when we actually look at whether we can or can't adapt. So under the lower scenario, California could adapt, but under the higher scenario, it couldn't. That actually sparked adaptation, understanding just what an unprecedented experiment we're conducting with our planet and how important it is to act now while we still have time.
So to continue along this, does solar geoengineering allow us to continue on this path that we're on now?
I think the short answer is no. Yes. It is certain, and there actually is now enough science. People have tried this in climate models. If you just kept emitting, so if you emit CO2, the amount of CO2 in the atmosphere keeps growing. If the amount of CO2 in the atmosphere keeps growing and you keep blocking out more and more of the sun, you just are walking closer and closer to disaster. There's no version of that doesn't end in disaster. So nothing about solar geoengineering changes the fundamental fact that if you want to deal with climate risks, you have to eventually bring net emissions to zero. But it's important to remember that the people will often phrase this as if, well, if we can just cut emissions, we don't need solar geoengineering. That really is incorrect, because even if we brought emissions to zero tomorrow, we'd still have lots of climate risk from the CO2 that's in the air. And if it's true, and we don't know that solar geoengineering could actually usefully reduce the risk from the CO2 we have in the air now, and without too many side effects, again, we don't know that, then it might make sense even if there were no more emissions. So I think more than people realize, the decision about whether or not to do solar geoengineering, in my view, is a ethical and technical decision about the harms of doing it against the benefits of doing it. And it's less dependent than you might think on exactly what emissions are doing.
Katharine, do you have any thoughts about whether solar geoengineering, I suppose just researching it, would lead people to believe we can continue on the emissions path that we're on right now?
Well, unfortunately, it already has done that. There are a number of people from the right-hand side of the political spectrum, starting with the Super Freakonomics book from quite a while ago, who basically take this as a get-out-of-jail-free card. And as David was entirely clear, and again, no one knows more about this than he does, other than maybe the National Academy of Science's entire committee, and I think they would say the same thing. It is not a get out of jail free card. We have to cut our emissions. We have to reach net zero. That is the only way to fix this problem. What solar geoengineering is potentially, we don't know for sure yet, but potentially it might offer a way to temporarily mitigate some of the consequences of our poor decisions. But what we need to do is we need to cut carbon emissions as much as possible, as soon as possible, and we need to also increase the ability of nature to soak up that carbon. Because nature wants that carbon in our soils, where it's a fertilizer. A healthy ecosystem is full of carbon. And so when we restore ecosystems, when we practice smart agriculture, when we take carbon out of the atmosphere, we are practicing a form of geoengineering, but it's one that has positive, constructive, beneficial results if done correctly, as with anything, and one that helps us to our net zero pathway.
And so, Katharine, you've just come back from COP26, and there's been a lot of focus in the coverage on things that were softened and watered down and all the fear that we should have. But is there anything from the conference that makes you feel optimistic about the next decade or so?
Yes, there is. Now, first of all, COP is mainly a reason for every government in the world to come together to re-examine their commitments to the Paris Agreement and to the original United Nations Framework Convention on Climate Change, in which they agreed to prevent dangerous human interference with the climate system. That's what they agreed to do. And now they've spent, how many years has it been? 30 years arguing over what is dangerous and how to prevent it. So I was not expecting the countries to all come together in Glasgow and have this incredible, oh my goodness, moment where it's like, yes, we will agree to do everything it takes to do whatever the scientists say. If they haven't done that in 30 years, why would they do it this week? So my expectations were somewhat low going in. I was not expecting a miraculous solution to everybody saying, yes, we're going to do everything we need to do. But what we did see increased ambition. If you include net zero targets, an analysis by Carbon Brief showed that current policies and pledges would take us to 1.8 degrees Celsius, which is a lot better than we were a month ago. We were at promises were up to about 2.7 degrees Celsius. We also saw the first mention of fossil fuels, if you can believe it, in the COP negotiations, countries agreeing to phase out subsidies from taxpayer pockets to the richest corporations in the world. We also had agreements to reduce methane emissions that are just leaking from oil and gas wells. We have enough methane leaking out of West Texas to power 7,000 households. And we saw agreements to phase out, which were watered down at the last minute to phase down, coal use, which, as David pointed out, from a health perspective, we shouldn't be using anyways. Particulate emissions from fossil fuels are responsible for 8.7 premature deaths per year. That is almost double the numbers of COVID. But every single year. So that is progress. But what gives me the most hope was not the governments that went to Glasgow. It was everyone else. There were tens of thousands of people there. There were children, parents, grandparents, young people. There were corporations, organizations, businesses, churches, Indigenous peoples, artists, activists. The world went to Glasgow. Why? Because the world realizes that it doesn't matter who you are, it doesn't matter where you live, it doesn't matter what you're passionate about, every single thing you already care about is being affected by climate change, and climate solutions benefit us all. So to care about climate change and to advocate for action, we don't have to be a certain type of person or vote a certain way or live a certain place. We only have to be one thing, and that is a human being living on this planet. And we're all that, and so that's why we all care.
And we're just about out of time. David, for our last question, could you let me know if you had unlimited dollars to tackle climate change over the next decade, where would you spend them?
I'd spend about 2/3 of it on emissions cuts, and I'd go really pragmatically after the big emission sources. That's driving more renewables into the system, capturing carbons from some big fixed sources like cement plants, et cetera. And I spend about 1/3 of it on adaptive measures like air conditioners for poor schools and social adaptive measures and so on. And then I'd spend a tiny amount that's literally less than 1% on all climate research, because to give you a sense, we need to spend about 1 or 2, I'd say maybe more, percent of GDP, so a total GDP on cutting emissions. So that's maybe $2 trillion a year or something globally. the amount we spend on climate science is like 10 billion a year. And of that 10 billion a year, I might spend a few percent of that, 5% of that or something on solar geoengineering. So less than 0.01% of the total. So I think the money on solar geoengineering research isn't the issue, even in the mind of the critics. The issue is really the consequences of doing it. And I guess I close by saying the thing that most excites me is the activist energy, which I think is a long run thing that drives change. And I think if I think there's anything really new that's happened in the last few years, it's the growing understanding that heat, high temperatures, especially for the world's poorest who live in hot countries, is a huge driver of impacts. It kills people, it makes them less economically productive, and it makes them learn less well. And I think that's one of the reasons I think that it's worth getting serious, not necessarily doing it, but about understanding the potential of solar geoengineering, because there really is a potential that could have special benefits for people who live in the hottest and poorest countries. And it could reduce the inequalities in ways that are meaningful, the inequalities that are driven by climate change. So to me, that's a reason to take it seriously, but I don't think we should advocate for doing it. I think the question is learning more.
All right. Well, David, Katharine, thank you both. It's been great to learn more about solar geoengineering and to also emphasize that the number one thing that we need to do is cut our emissions. So thank you both. Take care.